to my class. We are revising KCSE mathematics from the topic three-dimensional geometry. We have such a question. This is a cuboid, and the question was carrying 10 marks in year 2015. So welcome. So we go to the question. The figure below represents a cuboid. Make sure you read the statement, the question. The figure below represents a cuboid. This cuboid here, you check. In which EF is 40. EF is 40. Yes? FG is 9. FG is 9. Confirm whether you have all the measurements. GM is 30 centimeters. Good. N is the midpoint of LM. N here is the midpoint of LM. So the first question is, calculate correct to four significant figures the length GL. Length GL. Maybe I can use this one here, similar to that. GL. GL. This diagonal here, Lana. This diagonal here. The diagonal of this rectangle on this side. How will you calculate it, GL? So, if this is a diagonal, we know that this is 90 degrees here, 90 degrees. From here to here, we have 9. Here, we have 30. The height is 30 degrees. So, we just use Pythagoras theorem. This is one side of the right angle triangle, the other one is there, and GL is our hypotenuse. And therefore, part A, Lana, we will talk of 9 squared plus 30 squared should give you GL squared. GL squared. So this is 81 plus 900, Lana, to give you GL squared. GL squared. You add this, you get 981 is equals to GL squared, and therefore from there you find the square root using a calculator. You get 31.3209 and so on and so forth. But we are told to leave our answer to four significant figures, Lana. So you come from here 1, 2, 3, 4. This is 0, and therefore our answer will be that 1.32 correct to four significant figures. That is our GL, the diagonal there. We go to part B. What is FJ? FJ. Where is F? FJ. This one here. This diagonal here. Maybe I can fix it there with a ruler so that you may see it clearly, Lana. That is our FJ. How do we get this FJ? Which looks like a diagonal or a hypotenuse. What you do is that you come and introduce this diagonal which is down here. A diagonal there. And therefore, this is a height and this is a diagonal, and so this is 90 degrees. That is 90 degrees, Lana. So from there, Lana, we have a right angled triangle. So it forms a right angled triangle. We need to get this hypotenuse. So the height here is 30. What is FH? We don't have it, but again, it refers to the diagonal of the base. The diagonal of the base. So how do you find the diagonal of the base? This side is 9 of the base. This is 40. So we work out that diagonal by Pythagoras theorem, and therefore it will be 9 squared plus 40 squared to give us the diagonal of H squared. And so this is 81 plus 1600 is equals to FH squared. Yes, you add this, you get 1681 is equals to FH squared. You find square root, Lana. What will you get? Okay, using a calculator, you find square root, you get 41 centimeters. So, Lana, This diagonal is 41. 41. So, using our triangle here, we want to get what? FG. So we can even extract that triangle so that we can see it clearly, like that. This is J, this is H, this is a right angle, and this is F. Yes? So this here, we have calculated the diagonal is 41, and the height is 30 centimeters. So Pythagoras theorem again to get this hypotenuse. And therefore we talk of 30 squared plus 41 squared is equals to Fj squared. So this is 900 plus what? Plus 1681 to give us Fj squared. You use a calculator learner to add that. You add that, you get 2581 is equals to Fj squared, and therefore using a calculator Fj is what? Square root. You get what? You use a calculator, you get 50.0. 50.80, correct, to 4 decimal places. 4 decimal places. That hypotenuse there. So you use Pythagoras theorem. Lana, we go to part C. Part C, Lana. The angle between EM and plane EFGH. EM and plane EFGH. The bottom plane. EFGH. EM at plane EFGH. EM at the bottom plane. So let us draw our EM here so that you can see it clearly. EM, line EM line, and the bottom plane. Again, you can see it looks like a hypotenuse. You see that one there. So what is the angle between this one and the bottom plane? The angle between a line and a plane line, the bottom plane, is the angle between this line and its projection. Its projection on the plane. Where is the projection of this line here? The projection will be what? It will be EG. EG, line EG. How? If you had a beam of light directly above this, M would come here and E would remain in the same position. So joining E to G line, you'd get the projection. The projection. So I come and draw that projection. So I come and draw our projection there. So the angle between this line and the bottom plane is the angle between this line and this projection, and therefore it is this angle here. And this vertical and this diagonal meet at 90 degrees, Lana. We are in part C, Lana, and therefore we get this angle. We can redraw this triangle here, like that. Yes, this is M, this is G, and this is E. And we want that angle there. We have the height here, which is 30. What about EG? EG is the diagonal. The diagonal of our base there, which was 41, is the same as HF. It's the same as HF. So it is 41 down there. EG is a diagonal just like this one. And therefore you use tan theta. Tan theta therefore is equals to 30 over 41. So tan theta is equals to what, Lana? You use a calculator and you should get 0.7317. Okay? Then what is theta? Theta is equals to what? Tan inverse of 0.7317. Which angle is this? You go to the calculator and you work it out very fast, the angle would be 36.19 degrees. 36.19 degrees. Yes, we go to part D, Lana. Part D, the angle between planes EFGH and ENH. EFGH, the bottom plane and the plane ENH. That triangle inside there. So we come and fix our triangle, our plane. Here we are, our plane. EN. Between ENH and the bottom plane is what? You come to this isosceles. This is an isosceles because this is equal to that. You drop a perpendicular to the line of intersection there. This is the line of intersection. And then you move from the bottom plane all the way up to there. All the way up to there. So the angle is what? This is the angle, Lana. There. Angle. We can call this N here. Angle M, N. We can call this Y. M and Y is the angle between the two planes. So you drop a perpendicular there and you continue it with it on the other plane there. So this is the angle. Maybe we can drop a height from here. A height from there. And therefore, maybe we can extract that triangle. Let us extract it. We extract it so that we can see it clearly. This is N. That is, oh sorry. Suppose we call this P. P. And this is Y. So, this is the angle that we want. This height here is 30, the height of the cuboid, and this length here is what? The length of the cuboid, 40. And so, how do you get theta? You talk of tan theta. Tan theta is equals to what? Opposite over adjacent. Tan theta, Lana, is equals to what? 0.75. You look for tan inverse. Tan inverse of 0.75, and therefore using your calculator you will see that that angle is 36.87 degrees. Yes. Now we go to the last part E, Lana. So part E, the angle between EH and GL. EH, Lana, is this line. And GL is this one here. EH and GL. The two lines are not meeting anywhere. And therefore, Lana, you have to make them meet so that they form an angle. So what we do is that you translate these lines this way so that it finally lands on FG. So that they finally land on the same plane to form an angle. So you translate, we call it translating. Translate these lines so that finally it falls on FG. So we write that you translate line EH to lie on FG. To lie on FG. And therefore, Lana, this is now like our line FG. And it is meeting with line what? It meets with our line GL here. So in other words, we are looking for this angle here. This is the angle theta. And this angle here is 90 degrees. So I think I can extract that very fast here. So this angle, this is L, this is F, and this is our G. This is 9 centimeters, and we want this theta. Our FL is what? 30 degrees. I is 30 centimeters. So how do you work out this, learner? To work out this, you use tan. To work out this, learner, you use tan theta. So you talk of tan theta is equals to 30 over 9. So tan theta, you get the decimal, it gives you 3.333. And therefore to get theta, learner, you look for the tan inverse of 3.333. And so, learner, using a calculator, your theta should be 73.30 to 4 significant figures. 73.30 degrees to 4 significant figures. So go and do more practice on three-dimensional geometry, learners, and you'll do very, very well in your exams. So bye-bye.